Now let's have a look at question 8a. A pulley system has two pulleys in the upper block and two pulleys in the lower block. Draw the system. And part 2, if a load of 300 newtons is raised by 125 newtons, then calculate the MA, the mechanical advantage. Now I'll draw the pulley system with two pulleys in the lower block and two pulleys in the upper block. So totally there are 4 pulleys, and such a block and tackle pulley system will have ideal mechanical advantage equal to 4 because there are 4 pulleys or 4 string parts balancing the load. The topmost pulley and the bottommost pulley are obviously the biggest. It's always easy to draw the diagram starting from the effort. So from the topmost pulley, the string will go to the lowermost pulley, and then to the pulley 1 below the topmost one, then one above the lowermost one. And finally, since we don't have any more pulleys, the string will go to the hook. As I can say, it is being tied to the upper hook. Now the tensions are going to balance the load. In fact, there are 4 tensions, 1, 2, 3, 4, which are going to balance the load. So we can say load is equal to 4 times tension, and this effort is balanced by 1 tension. So consequently, I can say mechanical advantage is load upon effort. So 4 times tension upon tension from here, and as a consequence we can say MA is 4. However, this is ideal MA and not the real MA. The real MA is what we have to calculate. So the real MA can be calculated by using the simple formula. MA is load upon effort. The load is 300 newtons, the effort is 125 newtons, and as a consequence the MA turns out to be 2.4. Obviously MA does not have a unit as it is a pure ratio. Now question 8b, define the term dispersion of light. And part 2 of that question, why does sun appear reddish early in the morning? So now, first of all, what is dispersion of light? I'm sure everybody knows that dispersion of light is splitting up of white light into its 7 components when passed through a prism. So splitting of white light into its 7 components when passed through a prism. Next subpart, why does sun appear reddish early in the morning? It even appears reddish in the evening, that is at sunset. So basically at dawn and dusk, sun appears to be reddish. So the answer is very simple, that at sunset and sunrise, the sun is always below the horizon. So if this is the earth and this is the horizon line, then the sun is somewhere out here below the horizon line. Now suppose this dotted line represents the boundary of the earth's atmosphere, then light coming from the sun goes through a huge layer of atmosphere before refracting and reaching an observer out here. Now as a consequence, a large amount of light is scattered out here, and since smaller wavelengths which are violet, indigo and blue are scattered away out here, the light reaching here to the observer is going to be rich in red, yellow and orange, which are the longer wavelengths, and therefore the sun appears to be reddish. So basically at sunrise and also at sunset, light from the sun undergoes large amount of scattering, and this is because it has to travel through a large layer of atmosphere. And as a consequence, and therefore the smaller wavelengths are scattered out even before they reach the observer, and therefore the sunlight reaching the observer is rich in red light. So sunlight reaching the observer is rich in red, which is the longer wavelength, and scatters the least, which is the longest wavelength and scatters the least. Now have a look at question 8c. Two simple pendulums A and B of different lengths are suspended from the same string as shown in the diagram out here. So A is of a longer length, B is of a shorter length, and this is the common string from which the two pendulums are suspended. When A is made to oscillate, it is found that B also starts vibrating. So A is set into vibration, and obviously automatically B will start oscillating. Name the phenomenon responsible for vibration of B. So B is obviously vibrating under the influence of A, and as a consequence we can call it forced vibration. And this is especially so because B is not going to vibrate with its own natural frequency but that of A. So B is undergoing forced vibration as B's frequency is not equal to that of A. So basically I am ruling out that there is resonance between them. Does the frequency of B depend on its own length or on the frequency of vibration of A? So obviously since A is setting B into oscillation, B will vibrate at frequency of A. So now the third part, what would happen to the amplitude of vibration of B if its length were made equal to that of A? So if length of B is made equal to that of A, then B will be set into resonance. And if it is set into resonance, its amplitude of vibration will increase. This is obviously because there will be complete transfer of energy from A to B in such a case. And the fourth part, name the phenomenon that occurs when the length of B is made equal to that of A. So I've already mentioned it in my previous subpart that the phenomenon is resonance, as not only the lengths match, but when the lengths of the two pendulums are equal, their frequencies are also the same. So frequency of A matches frequency of B. At this point I would like to remind you all that we have studied in lower classes that time period of a pendulum is given by the formula 2 pi square root of L over G, which means the time period of the pendulum depends only on the length of the pendulum, that is the effective length technically, which is the distance between the point of suspension and the center of gravity of the bob. And apart from that, time period depends on acceleration due to gravity. So in that case, we can write frequency, which is reciprocal of 1 over time period, as 1 over 2 pi square root of g upon L. So technically, the frequency of a pendulum only depends on acceleration due to gravity and the effective length of the pendulum. Now, since in case 3 it is said that length of A is that of now since in case 3 it is said that length of B matches length of A, the frequencies will also be the same in accordance with this formula.